Hi, my name is Adam from cloudautomation.blog. In this video, I'm going to go over the value of a cloud management portal or a cloud management platform, commonly referred to as a CMP, and the value it brings to the business in regards to consuming public cloud services. From talking to enterprise after enterprise, I'm pretty sure most of ITO or IT operation, the people actually doing everything that you see on the screen, all the manual tasks it takes to build a server, understand the value of a CMP and understand the value of automating and orchestrating as much as possible. Where we start to lose some traction is when I'm talking to a CIO or a CTO or a director of applications or even a developer. As soon as I say this is a CMP and this is why you should consider it, the first question I get is, why would I need a CMP? And usually coming from a director of applications or a manager of an application or a project owner or even that said developer, that question is driven from, I have to go submit another ticket. What's manifested in I have to go submit another ticket is it's going to take 1 or 2 or 10 weeks to get that server, just to get that simple server. And I've been out in the public cloud as that developer that I'm talking to. In the back of their mind, they're saying, I can go to Amazon today, I can go to Google today, I can go to Azure today, and I can go get a VM, I can go get a database, I can go get said service within 5 or 10 minutes. I can get everything I need within minutes, and it's going to take IT weeks and weeks to do that. Why do I need to do that? Already out in the public cloud today. So first, I'm going to address why we need it, and 2, I'm going to show you how we mitigate any concerns around access to the console and some of the cool things that we can do. So first off, I just want to quickly talk about what a CMP does and how it all ties together in a DevOps culture or in a digital transformation, whatever kind of keyword you want to use. A CMP is essentially a portal where admins can go define services and consumers can go consume said services. So for a VM, it might ask you for something like a VM server name. How many CPUs? How much memory? How much disk? What type of operating system? What type of application? So is this an IaaS server? Is this a JBoss, a WebSphere, a Tomcat server? Who will actually be paying for this? And that's key because in the public cloud, we're not paying funny money. We're not paying just our internal finance department. We're paying actual green dollars. We need to know who's paying for it. So a consumer will go in there, they'll fill out all those fields, they'll click submit. And what that ties to, what that submit button is doing is it's tying to an orchestration engine in the background. And what we're looking at right now is an orchestration engine. It's HPOO. But there are a slew of orchestration engines out there that will all perform this exact same function. vRealize Orchestrator, which is, in my opinion, a market leader. There's ServiceNow Orchestration. There's System Center Orchestrator by Microsoft. And then the one we're looking at right here, it's HP Operations Orchestration, or as it's newly rebranded, Micro Focus Operations Orchestration. So as soon as that end user clicks submit, it captures all of those inputs. And it passes it over to an orchestration engine that will actually do all of the work. So you can see here in the properties, here are some inputs from the end user. So you can see the volume disk name, the instance description, the machine type, which is the size. One thing to note in the public cloud, you don't get 1 vCPU and 4 gig of RAM. You get a size that may be 1 vCPU and 4 gig of RAM, but you actually have to specify that size. The VM name, which is actually the server name itself, the project ID that we're billing it to, the zone, right? We want to actually put this somewhere. So you can see here, it's US East 1B, that's a static input. And then it captures all of that data and we start executing things. So you can see here, these are all the manual tasks that would happen today in an enterprise. We're doing some very tactical things up front, but you can see here we're actually creating an AD artifact. We're deploying an instance. We're creating a ServiceNow CI and a change control. And all of these things actually happen in this workflow. Everything after this, just for the purposes of this demo, to demonstrate the value of a CMP, everything after this actually doesn't do anything. But these are real things that happen in an enterprise. I usually see about 15 to 20 different items like this within a full server build. And this is key. This is really the value of the CMP. So after this, we can see we're going to do some parallel tasks, which means we can get things done even quicker. These steps manually might take a human 5, 10, 15, 20 minutes maybe. Through orchestration, we can now do those 5, 10, or 15-minute tasks within seconds. And not only can we do them within seconds, we can do them in parallel. So you can see here, we're going to create a backup node. We're going to add this server to monitoring. We're going to update some tags, and tags are key. That drives billing. That drives GRC. That drives security requirements. That drives application decisions. That might drive spin up and spin down. Dev servers, we might want to spin down at 5 p.m. and turn back on at 8 a.m. when the developer shows up. Production, we probably don't want to do that. We're going to add it to a backup schedule. We're going to install some IPS IDS. Maybe we're going to install some packages using Yum or apt-get or SCCM, depending on if it's a Windows or Linux box. We're then going to install a configuration management tool. We're then going to classify that server. So installing it just installs the agent. And now we said, hey, Puppet, hey, Chef, this is a WebLogic. This is a WebSphere. This is an IIS server. Actually install that and configure that server to meet that standard. We're then going to add the server to Qualys or Nexpose, some type of vulnerability scanning software. And this might take a few minutes, but this is one of the last things that we do because the server is fully configured. We want to update that ServiceNow CI, so your ITSM CI within the CMDB. And then the very last thing we're going to do is close that Snow change control, that ServiceNow change control. So all of these steps, whether we're in dev, QA, or production, are needed to actually build a server. So let's take a quick look at how this actually ties into a CI/CD pipeline or a DevOps pipeline or a digital transformation of a business. So I was going to create a CI/CD or a DevOps pipeline chart, but I jumped on Google real quick, and I really like this one. So let's quickly go through this. Whether you've seen something like this or not before, hopefully I'm going to describe it in such a way that you'll understand how this all ties together. So over on the left, you have some developers doing work within their workstations. They're submitting code to a system of record, so some type of version control system. It's going to run some unit tests. It's going to check some packages and make sure packages are actually installed. We're also going to publish those packages to an artifact repository. We're going to promote the code to a test environment. We're then going to run some additional tests, so regression tests, performance tests, compatibility tests. And if that succeeds, we're going to push it as a completed package to the Artifactory repository. Now that we're here, someone within a QA department could actually spin this up, run some user acceptance testing. If there's any issues or problems, they can do a feedback loop to a QA developer, and then this whole cycle would start over again. Going back to here, we can now look at the system administrator, and now he can spin up this application into staging to do some testing. If the post-deployment tests succeed, the sysadmin is happy, and we can now promote that to production. Now, how this ties into a CMP, an orchestration engine, and specifically the public cloud, you're going to be paying green dollars for all of your servers. So the one thing I want to note about this diagram that is not correct, but I thought it was a very good diagram and I wanted to use it, is you'll see here static PIGA 7 system. To tell you the truth, I have no idea what PIGA is, but in your data center, most likely all of this, everything you see here is correct, except it's not a static PIGA 7 system. It's a static set application system. So within your data center, your application teams, they probably have 2 or 3 or 5. I've seen as many as 7 or 8 environments. So a dev, a test, a pre-prod, a sandbox, a staging, a UAT, all of these different environments, and they might be 2 or 3 or 10 servers each. And they're up and running for 2 or 3 or 5 years, whatever your depreciation schedule is for your physical hardware. And they're only used maybe an hour, a day, 2 days out of the month. So each environment is only used 5-10% of its actual time. And it's just sitting there and spinning. Now in your data center, that might be okay. But in the public cloud, that's going to be quite expensive. So what we want to do is we want to replace this static 7 PIGA system with some type of an API where we have a standard set of services that we can consume. And when a developer commits code, it will automatically stand up those services. So right here, it would automatically stand up the services. It would run the unit test, and then it would break those services down. We would then package that up, submit it to a test environment, which wouldn't exist. So it would also need to be automatically spun up within 10 or 15 minutes. We'd run those tests, and if that succeeded, we would break that infrastructure down. But the code itself, we would then promote it into, in this case, a QA repo. Now, why does this matter? Why does this whole process matter? Because in production, if I go back to that orchestration engine, in production, you need all of these things. You need the ServiceNow change controls. You need the CI. You need that Qualys scan. You need that IPS IDS. You need backup. Maybe we want to use native cloud backup, which I would always recommend that. But maybe we don't want to make too many changes too quickly, and we still want to use some other backup software for the next quarter or two before our backup operations team gets completely comfortable with cloud backups. So we still want to add it to backup. We still want monitoring. We still need all of these things in production. And what would happen if I do all of that stuff within production, but I don't do any of that within my development environment? Within my development environment, I have developers going out to the AWS or Google or Azure console. They're spinning up servers. They're doing what they want. They're installing packages. Who knows what's going on? Who knows what packages are installed? All of a sudden, there's a vulnerability with Apache or with Tomcat or with Java. And they've installed that vulnerable version, but it has a certain feature that they need, and they code to that. And then all of a sudden, when it gets to production, guess what? The application doesn't work. So what we want to do is we want to replicate our production environment within staging, within test, within development, within UAT. And the panacea I hear from a lot of CIOs and CTOs and directors of applications is, how do we do a blue-green within production? So how do we have blue out there already, and we spin up a green environment, we take this code, we apply it to that green environment, we do a load balancer, switch over to green, and then we break down blue. This is how you do it. That was my quickest version of what is a CMP and what value does it bring to an enterprise in regards to the public cloud. But this also applies to a private cloud on premises. The second thing I wanted to cover is, I'm a developer. And one thing CMPs don't do is give a developer all the cool day two operations that we can do within the console. Whether it's Amazon or Azure or GCP, we just can't provide all of the things that the console provides. So what do we do then? Because we don't want that developer, unless it's a pure sandbox environment, we don't want the developer going into dev, going into our test environments, going into our staging environments and spinning up servers and changing things. These environments should be spun up automatically through something like Jenkins, and then spun down automatically after the unit tests or regression tests or deployment tests pass. So let's jump into the Google console and take a look at how we can address this concern. So here we are at the GCP console. You can see I have a project HPO GCP. Some very basic information is provided to me, Compute Engine APIs, some really cool stuff. If I go over to the Compute Engine, we can see here I can create an instance, I can import a VM. If I select one of these, I can delete it, reset it, stop it. I can SSH to it. I can do everything I need to do within the portal. But what if I go back? I can also go to the Kubernetes Engine. Or if I click Bigtable, do I have access to that? Yes, I do. As an admin, I have access to that. So the point of a CMP is to limit the amount of services for GRC, for security, for billing, for management, for a slew of reasons. Limit the amount of services and limit the type of services our developers can spin up. We don't want to limit everything, but we want to put some guardrails around what they can consume. So how do we do that? While at the same time allowing them to consume services and do all of those things that I showed you in that orchestration engine. That's where Iam comes in. One really cool thing about the public cloud is the granularity of the Iam policies that are provided out of the box. So let's drill into Iam. And we can see here I have a couple different accounts. So this is my primary account, adam@cloudautomation.blog. You can see I'm the owner. And then I have a couple other accounts here. So this is a service account, and then this is my demo account. This is my actually developer account that I'm going to use to demo how to limit what that developer can do. So let's take a look at this developer account and what roles it has. So you can see viewer, compute OS admin login, and compute viewer. What does that actually mean? So under project, so I can view all of the projects. So I can view this project, there's viewer. What if I wanted to have access to BigQuery? If I was someone from finance, I needed to see billing. What if I was someone from the network team and I wanted to see some DNS information, storage team, data store information, the QA team, maybe some error reporting. But in this case, if I go up to Compute Engine, we'll see I can view everything within the compute as a read-only access to get and list information about all Compute Engine resources. And then I also want to give that developer access to log into the box with admin credentials. So it could be OS only login. So as a standard non-administrator user, you give them the network user, network admin, very, very granular access. So what does this actually look like now? So I'm going to switch over to this developer account. So you can see up here the same project. I can still view all of this because I am within that project. I can view everything within the project, but I can't click anything. Everything's grayed out. I have no write access. Now let's go back up to the GCP console. You can see again, I can view everything, so I can still see what's going on. I can still see everything that's pertinent within this project. But what if I drill into App Engine? Your first app, select the language. Well, that's kind of cool. Maybe I can create an app. Node.js. Nope, you don't have permission. Let me go to Bigtable under Storage. Can't create an instance, the button's grayed out. But what about Compute Engine? I should have some access here. So yes, the screen loaded, that's great. I can actually see the instances that are related to this project, but what can I do? If I drill into it, can I see any information? I should be able to. Hey, there we go, I can. But I can't edit the box. I can't reset it, clone it, stop it, delete it. But I thought I could actually SSH into it. Let's go back one screen and let's see if I can do that. Hey, there we go. Use another SSH client. So I still can do that. I hope this video cleared up, one, not only the value of a CMP in regards to the public cloud, but also two, how we can still allow our developers to access the public cloud consoles and the granularity of the IAM roles the public cloud providers give us to use out of the box. Lastly, I mentioned a few roles. I talked about CIOs and CTOs, application owners, and developers. As a CXO or as a director of applications, director of infrastructure, the purpose of this video was to provide you a high-level framework of how you can enable DevOps and how you can enable digital transformation and how you can enable whatever buzzword you want to use for today. When it boils down to it, it's setting standards, driving those standards while still doing everything that the business needs, all those GRC and security requirements. And if you're that developer and your organization does not want to go to the cloud because it's not secure or because they can't set those standards, this framework, what I just showed you, is exactly what you need to evangelize within your business. Show them this and drive this message home so you can take advantages of the features that the public cloud provides you. If you have any questions or comments, feel free to comment on this video, tweet me at automation_Adam, or shoot me an email. Thanks for watching and have a great day.